Next we discuss about WAP, which is known as Wireless Application Protocol, which is an international standard for accessing information over a mobile. It is a set of protocols which is used on wireless devices, and it is a standardized. It is a standard which is optimized for low display capability, low memory, low bandwidth devices such as personal digital assistants, PDAs, wireless phones, and pages. This WAP is not a markup language like HTML, CHTML or HTML, but it is a complete stack of protocols. And this is designed to overcome the specific problems caused by wireless networks during web access, such as latency, which means the delay in transmitting or processing data, and jitter, which is known as the variation in latency. But also this addresses the problems which are caused by the mobile device, such as small screen size and low processing power. This architecture defines an optimized protocol stack for communication over wireless media, a content description language, and a miniature browsers. It replaces the HTML pages with highly condensed WML pages called cards, which we have already seen. Here, this figure shows the traditional web access systems, which is shown in the figure itself. The client and application server communicate using the HTTP request and response streams. We now compare this mode of web access with from a traditional computer with a WAP-based web access. Here, this figure 10.2 shows WAP-based web access. In this, you can see that there is a client and a gateway and an original server, which is also known as application or content server. Here, in this WAP-based access web accessing method, all requests from the mobile device are sent to the WAP gateway. This is WAP gateway, and this gateway transforms them into HTTP request response streams and then sends to the application or content server. The reverse of the sequence takes place when the application or content server responds to a specific request. It is a responsibility of the gateway to convert a WAP request or response to an HTTP request or response. This conversion is very compute intensive. To handle this computational workload, the gateway needs to be a powerful computer. And this WAP is often described as a network-centric protocol. Most of the intelligence and computations associated with the WAP protocols are embedded in the network rather than the symbol form. The WAP Forum released its first specification of WAP, which is referred to as WAP 1.0 in the year 1997, and later it released WAP 2.0, and it had the backward compatibility with the previous WAP protocol. Although it has its own protocol stack, it is designed to be compatible with the internet, and all the pages in WAP are converted to the HTTP and TCP protocol at the gateway. And this WAP 2.0 provides support for the protocols that are counterparts of IP, TCP, and HTTP. It is also a flexible and bearer independent. That means WAP can run over any specific wireless data bearer technology such as SMS, GSM, GPRS, etc. Next, we will see the architecture of WAP 2.0 protocol stack that has been shown in figure 10.3. As can be seen from the figure, the WAP protocol operates at different layers, and this WAP defines its own specific protocols corresponding to the various layers of operation of the internet. Now we will discuss about the WAP stack and bearer services. Now, the first one is wireless application environment, which includes a micro browser on the device, then WML, which is known as wireless markup language, and WMLS, a client-side scripting language, telephony service, and a set of formats for the commonly used data such as images, phone books, and calendars. This is the application layer in WAP protocol stack. Next is wireless session protocol. Here, this layer provides a lightweight session layer. As you can see, it provides a session protocol layer, which is a lightweight session layer, allow efficient exchange of data between applications, and it creates a session between the WAP client and WAP gateways, and each session has an unique ID, and it should be started, stop, resume, or disconnected. It is based on the HTTP protocol and provides the basic session state management and facilitates reliable and unreliable data push, which is known as WAP push. The next protocol is wireless transaction protocol. It is an equivalent to the TCP layer in the TCP/IP stack, and this WTP transaction servers include reliable request and response, and it handles the problem of packet loss more effectively than TCP. Packet loss means it is due to atmospheric noise, signal fading, and handoff. In TCP, the packet loss is misinterpreted as a network congestion, but this is effectively handled in WTP. The next layer, and it provides the transaction support. This WTP provides the transaction support, adding reliability to the datagram service provided by the WDP. WDP is known as wireless datagram protocol, and this WTP makes sure that the packets sent through WDP actually arrive at their destination by waiting for an acknowledgement. The next one is wireless transport layer security. It is a security layer, and this is used to transfer data securely between a mobile device and a server, and it provides support, or its features are data security, privacy, authentication, and protection against denial of service attacks. The next one is wireless datagram protocol. As we have already seen in WTP, wireless datagram protocol is a transport layer that sends and receives messages through any available bearer network, and it is the bottommost protocol in the WAP protocol suite, and it is responsible for moving WAP data from sender to receiver and back again, and it provides a common interface to the upper layer by providing services transport of data in the unreliable wireless environment. And this WDP invokes the services of one or more data bearers such as SMS, GPRS, CDMA, UMTS, etc. And the last one is the bearer interfaces, and this is the low-level transport mechanism for network messages, and this is designed to operate with SMS to GPRS, UMTS, and IP. And you know that GPRS is relatively faster, and it provides always-on connections for wireless devices. And this WAP support circuit switched bearer services such as dial-up networking using IP and point-to-point protocols. This packet switched bearer services are much better than circuit switched bearer services because they can provide more reliable services in the unreliable wireless connection environment. This is all about the WAP protocol stack.